Hello everyone. So hope you all are doing fine. Today I will be presenting my DMW mini project, which is phishing site prediction. So what basically are phishing sites? So we all have came across the sites which redirects us to another site, and it basically uh, captures our password and our personal information, which is then used for wrong purpose. So nowadays, we all have antivirus softwares installed in our system, so it gives us warning before we enter any phishing sites. So I was just curious to know how does the antivirus software or any of the software guesses that it is a phishing site or not. So this was the main motivation of choosing this project. Before going to the project, like the process and the coding part, I would like to show you the outcome that we will get and at the end of the project. So this is a basic UI for my output. So it is we have to enter an URL to check if it is a, a good site or a bad site. So this is an example for a good site. So the predict, and it the output is given as this is not an phishing site. Now this is an example of a phishing site which is from a database. So when I use this as my URL, so it tells me that this is a phishing site. So this is basically my output of the model. So, for doing any project based on the data set, we are a data science project. So, we need to follow certain rules or certain process. So, this is the basic process. Now, define the goal. Now, I have confirmed that my goal is to predict if the site is bad site or a good site. So, I have defined my goal. Now the second process is to get the data set. Now to where to get a data set from. So there is an website called Kaggle from where I have got my data set. Before you choose the data set, you need to look at some of the points. Like here the usability is 10, which is very good. And then here you can see the tags. So uh, in dataset, more the entries, the good is the dataset. Now in this dataset there are over 5 lakh unique values, and they are labeled as good and bad URLs. So this is pretty good dataset for me. And also this dataset has unique URLs without any null values. So I chose the dataset for my project. No, as I said, my dataset has all unique values and it does not consist of any null values, which I will show you how I find it out. So I did not require to do this process, that is the cleaning of the data. So it was pretty easy for me uh, to choose the dataset and then use it in my project as it is. Now I will show you how the cleaning and all, like I how did I came to know that my data set is clean. So as we all know, before starting the program, we need to import some libraries. So these are the libraries that I am going to use in my program. These are quite large, and you do not need to worry about it, as you will know the functions of all of these libraries further in the process. So I was telling about the about had how I came to know about my data set is clean or not. So for knowing that, I firstly need to load the data set in my program. So I have used dot read function here, which loads my data set in my program. And obviously I have downloaded it from Kaggle. Now I have printed the head, that is first five first five entries from my dataset. So this is the first five entries, and it is labeled URL and the number, and the tail is the last five entries from your dataset. So as you can see, the last number is about 5,49,000. So it is near about, I have like file like 50,000 entries in my dataset. So it is quite large. And then I have just using Python for your data related project is a good idea because it has all the pre-built libraries and functions. So as you like as you use info, it will give all the information about your dataset. So here I will get like what are the columns, the URL and the label, and not null, like how many entries are there in my tape in my dataset that are not null. So there all the entries are not null, like they are unique and they are filled. So the count of not null is 0. So this is what I have predicted from that info. Then again to clarify, I have used the function is null and dot sum. This will give me the sum of in the null values from my table. As we have predicted above, there is no null value in my dataset. If if the dataset contains any null value, then we need to refine the dataset. So that's it. Now we came to know that our dataset is clear and it does not have any null values or any garbage values, as all the values are unique that we saw. So I did not need to perform this process, that is enrich of the dataset. I need to find insights and visualize. Visualize is basically to see what my dataset contains and derive the conclusions from my dataset. So what I have done here is count the labels, the bad and the good labels from my dataset. So I have a pretty good amount of good URLs from in my dataset, and to which the bad URLs are less. Now we cannot directly use the URL as it is for our predictions. So we need to only use the words that are present in the URL. So what we are doing is we are tokenizing the URL. Tokenizing is basically we are only collecting the words and removing all the special symbols or any integers which are present in the URL, and we are only collecting the words that are present in the URL. So here we are defining that only collect the words that is from A to Z, capital A to Z or small a to Z. Only this is what we want to use in our program. So we are tokenizing it. So here for example, I have printed my first entry from the URL, and this is the first URL in my dataset. Now when I tokenize the URL, this is the result that I get. So these are all the key, like the words that are in the URL. So not noble, the noble is separated, then the it is separated, and you can find that the full stop that is here, that has been removed. Again this value, that is the number, that is also been removed from the with the help of the tokenization. So once we have tokenized our URL, now what we want to do is, as we have an idea of what the tokenization does is, then we are tokenizing all the data, like all the data set into and creating an column that is text tokenized. And using this all my using this function, like using this cell, all the data will be tokenized from my data set. Now once I have tokenized my data, now I want to generalize the data, like the filmmaker, here the directors. When I generalize my data, so it will convert the directors to director, so it will be generalized. So it is basically known as steamed or snowball steamer that we are going to use uh, in this process. So what it will do is, it will give us the root word. now here we have scripts. So the root word for the scripts is script. So this snowball steamer will do is it will give us the root words for the tokenized words. Now I have then again added one column, and it will contain the steamed word. So now I have steamed all my data set. Now you can see here the plugins is uh, is been routed to plugin. So basically we have generalized the data. Now moving forward, as our algorithm did not know any list or anything, it needs an sentence to perform its work. So we are doing is joining the words that are present in this in the second list. So this function is doing what is joining the letters and creating it to a sentence. So this all of this words in the list are been converted to a sentence. Okay, so now comes the part of visualizing. So in visualizing, we will be saying what a good URL contains, what are the keywords, like the frequent keywords that a good URL contains and a bad URL contains. So I am just so, like separating the good URL and the bad URL in this variable, which is bad sites and good sites. So uh, and printing the heads of both of them. So these are all the, like the good sites contain all the URL which are not fake or not a phishing site, and the bad sites contain the phishing URL. Again, then as I said, I want to see which keywords are there in my good URL and in the bad URL. So this function is basically doing what is uh, collect going through all my data set and collecting a frequent the frequent keywords that are present in the good URL as well as in the bad URL. So firstly I am doing it for the good side, and visualizing is basically presenting what you can see in your data set. So this is nothing but just visualizing the data, and I have presented the keywords from the good URL in the star format, for which I have used the word cloud library, which I have mentioned uh, in importing the libraries. And then these are all the keywords that are present in my good URLs. And then for my bad side, I have printed the most common keywords. So these are all like the keywords that are present in my bad URL. Okay, so now we are done with visualizing our data and what our data set contains. We know all of that, and we know the keywords uh, present in the bad and the good URL. Now, what we want to do with this data and the insights that we have. So, as I said earlier, that when you click on a site, it redirects you to some other sites, and that site stole or steals your information. So for like we cannot go through all the sites at once, and as the site itself has many internal URLs that are interlinked. So for that we have an web driver. So what a web driver does is it basically parse through all your HTML code, and in the HTML code the addresses are saved with an A, like the A and href. So the driver basically scans all of your HTML page or the website uh, without like us going and manually doing it. So I have used the Chrome web driver here, and I have used this site which is I will show you how it is. So this site I have used for parsing and for the example. So here beautiful soap, what it does is it parse through your HTML code, and it finds all the A tags. A tags are basically used for storing the address, and then the href is where it where it goes. Okay, so we are storing all of this in a list URL. So this is the site that I have used, and this is the web driver basically. uh, so my web driver will pass through all of this site, and I will show you how I will get the result and and to the URL are connected. So I have, with the for loop, I have passed the web page, and I have stored the information, and the column includes for and to. Like I have entered the this URL, and from this URL I have redirected to this URL. So there are many such URLs that you are being redirected to. So for visualizing this, I have drawn this graph. So here you can see this is the main website that we were interested in, and this main website is redirecting you to all of these other websites. So you can see that it is pretty much large value that you are been redirected to. So yeah. Now, as I have all of the things present with me, I have the web driver which will parse my website that I am entering. I have the data set which from which I have the keywords that I will be using to identify the good and the bad URLs. Now I need an algorithm which will do this work for me. Now, while choosing the algorithm, we need to know the basic ideas, like what algorithms are present. For now, I want to like binarily classify my URLs into good and the bad. So for this, I will use logistic regression. So what logistic regression does is it trains your data set. Like basically you will be like dividing your data set into two parts, and with the help of training data set, it will draw this line. The main motto for the logistic regression is to draw this line, and this line will separate the good URLs and the bad URLs. So when you enter any new site, okay, so based on the keywords that are present in the new site, this line will classify it into a good URL or the bad URL and place it into that region. So for this purpose, I will be using the logistic regression. Now uh, now creating the model. So, as we all know, the machine learning algorithms or even our system does not know our language. So, we need to create an or we need to vectorize our data. So, as our data is in the sentence format, so we will vectorize it with the count vector, and we will fit it in the, like we will fit the text, the sentences that we gained earlier, and we will convert it into the array. So this is a sparse matrix. So as we have a little idea about the sparse matrix, it contains lots of zeros and some values like the some ones. So this is the sparse matrix for our vectors. Now splitting the data, as I said earlier, that we will be training our data first and then testing our data. So in this, we will split our data into train x, train y, and test x, test y. Now from here, the main algorithm of our logistic regression starts. So this is a predefined function of logistic regression. So in this, we will like we have created an object LR for the logistic regression, and we have fit. Like the meaning of fit is we are telling our function that if you have to learn this, and then when you have to learn all the uh, what we can say, all the methods or all the functionalities that are present in the data. So this is basically done with the fit, and then we will test it with our test data set. So when I use like score in the test data set, it gives me like the score of 0.96, which is a pretty good score. Then I will test the accuracy for my training and the testing data set. Now as I have fit or I have trained my data set, I can test it. The accuracy for my training data set is 9.7, and that of my testing data set is 9, like 96, and for training is 97. So this is basically like seeing how your algorithm is working. And this is the confusion matrix. Confusion matrix is basically a visualization of how good or bad your algorithm is performing. So it has four columns, as you can see, like the four regions. This region is the actual bad and predicted bad. Like this is a two values, this and this. This is also predicted good, and actually the value was good. So this, uh, the more the number of values in this two like regions, it is good for our algorithm. And you can see like there is a less number, like comparably less number in these two regions, so our algorithm is working pretty good. Now as all the steps for our algorithm are completed, now we will pipeline. Like what pipeline is adding all the processes in sequence that we have done till now. So firstly we have vectorized, then tokenize the data, and yeah, and then perform logistic regression. So after this we have split the data in testing and training data set, and then fitted it. So this is basically the pipelining, and then the score. This is what we have done earlier. So yeah, now as as all our things are over and pipelining is done, now we can dump it. We are using pickle here to dump it. Pickle is basically similarly to the pickle that like the meaning of pickle in our day-to-day life. It is like work on all of your programs and store it. Like if we store it, then it can last for many days. So this is basically the pickle which will create an model for me, and I can store it with me and use it whenever I need it. So I have used pickle to dump my algorithm, and then I have and yeah, as I said that we can use um, the the dumped model whenever we need it. So here I have again loaded the model. When we dump an model, it gives us a file with .pkl extension. So whenever I need the model, I will just call pickle.load, and this file is not like the .pkl file is not readable for us, but our machine can read it. Okay. So after loading the file, I have called the model for my test data, and again my test value is 96. So yeah, this was it. And again I have just, for my confirmation, I have used this prediction for good and the bad. I have used some URLs here which comes in the category of good and the bad. And again I have loaded the model, and for result I have printed the results here. So for the predicted bad URLs, which contains all the bad URLs, it gives me a result as all the four URL are bad, and for the good is it is the result I got is all good URLs. So yeah, that was all about my model, and I will provide the link for this for this in the description, the GitHub link. You can get the code over there. Thank you. Have a nice